Welcome to the parabola where the vertex is not at the origin. So to review, our standard form formula for a parabola is x squared equals 4py and y squared equals 4px. Now both those formulas imply that the vertex is at the origin. So here's the graphical review of the standard formula for the parabola where the vertex is located at the origin. Okay, up until now, these parabolas haven't been too awfully difficult. Just a little bit of practice, you can figure these out. But they've all been with the vertex at the origin. So it gets a little more complicated, but it's still not that hard if we practice and work through the steps. But when we move the vertex off the origin, we end up with a formula similar to what we used in circles. So if you remember back to circles, this is not that big of a jump. So we're giving the equation, we're being asked to find the equation of a parabola with focus at 1, 3 and a directrix at y equals -1. So because it's a focus at 1, 3, we can see one of those numbers is not 0, so we're off the origin now. The parabola is away from the origin. And the best thing to do is just go with what you know, slow it down and step it out. So let's put in, the first step that I'm going to do is put in the 1, 3 focus. I can plot that right here, and that's plotted in the black. So we can see the focus is at 1, 3. The next step is to plot the directrix, y equals -1. So if we go to y-axis and go to -1, there's the directrix in red. We've got directrix at y equals -1. So right away now I can tell that this parabola is opening towards the positive y-axis. So I should be thinking in my head about the formula x squared equals 4py, the standard with the vertex at the origin. I also can tell, I already know that the from plotting the focus and the directrix, that the vertex is now at 1, 1. It's right in between the focus and the directrix. So if I count up all those little squares and then divide by 2 and then move up from the directrix and put that vertex dot, that green dot, right in the middle there, I know my vertex is at 1, 1. Okay, but back to our standard formula, x squared equals 4py. I know I'm opening towards the positive y-axis. Now I'm going to put in my standard formula that's not at the origin. So I'm just going to put in my h and my k's, which are my x offset and my y offset. And just like circles, it's going to be minus because it's describing how far away from back to the origin, how to get back to the origin. So if I do that, I've got x minus h, that entire quantity squared equals 4p, and then my new y is my y with my minus k offset. Okay, so that's my standard parabola formula that's not at the origin. So we've added in the h and k. So in this example, we've got an h and k that we can see is the vertex offset, and that is 1, 1. And just like I was saying in all the other previous, that p is the distance from the vertex to the focus. And I've been saying that way intentionally so that when we get to this point, it makes this step easier. Because now I've got the vertex and I've got the focus, and I just can count that. I can go and count that distance, 1, 2, in the positive direction. So p is equal to 2. So now the next step is to build this formula out. I've got my negatives in there, set in there now, and we're going to go put that into Desmos and see if that looks like what we predicted for our parabola. Okay, so here's the formula put into Desmos with x minus h quantity squared equals 4p y minus k, the quantity y minus k. So just like we had it in the previous slide, and I'm going to set my variables h and k to 1 and my p to 2. Now comparing that to my previous prediction with the directrix and the focus and the vertex, I can see that my vertex is in fact at 1, 1. And if you drew in your directrix and your focus and made some measurements, right, you can make the measurements from the directrix to the parabola and then from the parabola to the focus. All those points should be equal. Okay, and in this slide we're showing basically the difference between standard form and general form. So if I take my equation that I just derived built in standard form, which was represented by this top parabola, and you can see the equation off to the left in the Desmos, and the p and the k and the h all set to the numbers that we had. And then if I do the math and multiply that all out and set it equal to 0, that is the general form. And just to show you that the general form and the standard form for the parabola are the exact same thing, and mathematically they're the exact same thing, I'm putting the general form also into Desmos, and you can see on the bottom parabola that formula right there produces the exact same parabola. So standard form versus general form.